All right, this video is all about solving absolute value equations. All we got to do is just follow some steps. We're going to isolate the absolute value on one side of the equation, and then we're going to ask ourselves, is the absolute value set equal to a negative? We'll talk about that. Set the quantity inside the absolute value equal to positive and negative the quantity on the other side, and solve, then check. Let's see it. So first, let's start with just the question, what's the absolute value of 3? Well, it's 3. What's the absolute value of negative 3? That's also 3. Well, then you have to ask yourself the question, if the absolute value of x equals 3, what does x equal? Well, x could have been 3 or negative 3. It's because of these two possibilities that each time we're going to have to set whatever's inside of the absolute value equal to the positive and negative of what's on the other side. Just to make some connection to what we're actually solving for, we can take this absolute value of x, subtract the 3, and set this equal to 0. When you set something equal to 0, you're solving for x-intercepts, which are also called solutions. Now this is an absolute value graph that's been shifted down 3. And let's look at where the x-intercepts would be. And look at that, just like we guessed on the page before, they are at negative 3 and 3. These are the two solutions to this absolute value. So let's look at it whenever it's a more complicated equation. All right, so here we have the absolute value of 2x minus 1 plus 3 equals 6. The first step is to isolate the absolute value on one side of the equation. That just means get rid of this plus 3. So we're going to subtract 3 from either side. So now that we've got this isolated and it's set equal to 3, we ask ourselves, is the absolute value set equal to a negative? No, it's not. If no is the answer, then we can continue. So the next step is to set the quantity inside the absolute value equal to the positive and the negative of the quantity on the other side. All right, so we have 2x minus 1 equals 3 and negative 3. Now it's time to solve both of these equations just using algebra skills. So just in this first one, we're going to add 1 to each side, and then we'll just divide by 2 to get x is equal to 2. We can do the same steps on the other side. 2x is equal to negative 2, and dividing by 2 gives us x is equal to negative 1. So this has the solutions x is equal to 2 and to negative 1. Now we have to go back and check our answers to a negative 1 to make sure that they satisfy the original equation. You can just do this talking to yourself. If I plug in 2, 2 times 2 is 4, minus 1 is 3, absolute value of 3 is 3, plus 3 is 6. If I plug in negative 1, I get negative 2 minus 1 is negative 3. The absolute value of negative 3 is positive 3, plus 3 equals 6. So both of these work. Let's try that one more time. This time we have a 2 out here on the outside of the absolute value, but I need to get this thing by itself first. So I'm going to start by dividing both sides by 2. All right? Now that I've got the absolute value by itself and it's set equal to a positive, I can continue just by setting it equal to both positive and negative 8. All right, solve. You're more than welcome to pause the video to go through these steps, but it was just the same steps that we used in the previous equation. And we ended up at x equals 3 and negative 7/3. Your job would now be to check, but I'll assure you these are the answers. All right, if we wanted to do it again, we would subtract 10, and we'd end up with the absolute value of 5x plus 4 equals negative 8. Now you have to stop yourself and say, what? This absolute value, this cannot equal a negative because we cannot have a negative distance from 0. In the other examples, we can take what's inside and set it equal to a negative, but the absolute value itself cannot equal a negative. So what we're going to say is that this absolute value has no solution. And another way that we can indicate no solution is with this circle with a line through it. That's called an empty set. All right, here's a challenging example where we have the absolute value of 2x plus 3 set equal to 3x minus 1. The first thing I want you to notice is that we have a variable both inside and outside of the absolute value. So whenever you're setting up your equations, you of course set 2x plus 3 equal to 3x minus 1. And just like before where we take the opposite of whatever is not in the absolute value, you have to remember to take the opposite of the entire right side. which would give me 2x plus 3 is equal to negative 3x plus 1. And now we can go through and solve these like normal. Let's start with this left side, just subtracting 2x from each side, just because that's going to leave me with 1x over here. And after I add 1, I have 4 is equal to x. Now on the other side, I decided to add 3x first because I like to keep my x's positive. And then subtracting 3, finally ending up at x is equal to negative 2 over 5. All right, so I've got to remember to check my solutions. If I check 4, 2 times 4 is 8, plus 3 is 11, equals 3 times 4 is 12, minus 1, which is also 11. So 4 works out. Whenever I plug in negative 2/5, notice that this right side will be negative. A negative number minus 1 is going to be negative. So we didn't even have to evaluate anything, but we know that an absolute value cannot equal a negative. So this answer will not work, and we call it an extraneous solution. An extraneous solution is a solution that worked out mathematically, but it does not satisfy the original equation. All right, and now it's your time to try. Good luck. All right, in working through these solutions, the answers are x equals 4 and x equals 0. And that's solving absolute value equations. Goodbye.